Welcome to today's video. Today we're going to be focusing on solving quadratic equations by factoring, and we're going to show this mastery in class by scoring at least an 80% on our exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet of paper so you can still take the notes, and we'll get you a fresh one when you get to class tomorrow. Now, when it comes to solving quadratic equations, there's a couple different ways they're going to ask you to do this. They're going to ask for a solution, they're going to ask for the roots, they're going to ask for the x-intercepts, or they're going to ask for the zeros. You can see it written all those ways, and the same thing is going to be said. You need to solve it. If you look at the graphs, and we're not going to graph them today, but there's three different types of solutions you can have. It can either hit the x-axis twice and have two solutions, hit the x-axis once and have one, or it doesn't hit the x-axis at all, so there are no real solutions. It's still a quadratic, but there's no solutions to it. Now, when we factor it, we're going to start everything that we did last unit. We're still going to factor the equation like normal. Do your ABCs. You can either factor by grouping or use the slide method. Once you're done, you want to set that equal to 0. That's how we're going to solve this. Now it's become an equation. If we set it equal to 0, that's telling me that y is equal to 0. Well, if I want it to be on the x-axis, y has to be 0. We're going to solve, and then we're going to set our answers in brackets. It's going to be x1 and x2. Remember, we want it in increasing order, just like your answer choices are going to be. Now, if a quadratic equation cannot be factored, it's called prime. We've talked a little bit about this, but if it's prime, it does not have real roots or x-intercepts, and it's going to have to be solved using a different method. We're not going to focus on that today, but I want you to be introduced to it. So, if we look at our first problem, x squared plus 7x plus 12. There is no GCF, so if I do the ABCs, A is 1, B is 7, C is 12, well, AC makes 12, and it's positive, so I need to add. 4 plus 3 gives me my 7. So when I factor, I'm going to end up with x plus 4, x plus 3, and that's going to equal 0. Now, from here, this is where it becomes a new topic. You want to take each set of parentheses and set them equal to 0. So I'm going to take x plus 4 equal to 0 and x plus 3 equal to 0. Now you're just going to solve for x. So if I solve for x, I'm going to subtract 4 on both sides. I get x equals negative 4. Over here, I'm going to subtract 3 on both sides, and I get x equals negative 3. That means my solutions to the problem are negative 4 and negative 3. In order to find my solutions, you have to set them equal to 0. Now, the second question asks you to find the roots. In this case, if we look, we don't have it in the quadratic form. We have a and b on one side and c on the other. When you set it up in quadratic form, my suggestion to you, always try and keep your a positive. Now, it'll still work if a is not positive, but make your life easier. I'm going to add x squared to both sides. I'm left with x equals x squared plus 12, and then I'm going to subtract x. So I'm left with 0 equals x squared minus x plus 12. Again, we always want that 0 there to be able to solve it. Now, if I do my ABCs, A is 1, B is negative 1, and C is 12. Well, AC is positive 12, so we're going to add, if I look at all my factors of 12, none of them add to 1 or negative 1. So in this case, when it's saying find the roots, this is a prime equation. We don't know how to use the quadratic formula yet, so don't worry about trying to solve it another way. For today, we're just going to call it prime. Our third example, we need to find the x-intercepts. Well, that's the same thing as finding the solutions. So again, I need to get it into quadratic form and equal to 0. So I'm going to add 2 on both sides, which gives me x squared plus 2x plus 2 is equal to 0. Well, now, again, I can do my ABCs. A is 1, B is 2, and C is 2. AC multiplies to give you 2, and it's positive, so we want to add. Well, if I add 2 plus 1, I get 3. 3 is not the same thing as 2 as our B, so again, this equation is prime. Our fourth example is asking us to find the zeros, which is the same thing as finding the solutions. It's already in quadratic form. I have a, b, and c, so I'm going to do a is 1, b is 10, and c is 25. Well, AC makes a positive 25, so I need to add. In this case, 5 plus 5 gives me my 10. So I'm going to break this apart to x plus 5 and x plus 5 and set it equal to 0. Now, to find our zeros, we need to take each set of parentheses and set them equal to 0. In this case, if you notice, they're both the same, so we only have to do this one time. Subtracting 5 from both sides gives me x is equal to negative 5. So my zeros, even though there's two sets of parentheses, they give you the same answer. So there's only one zero, and it's at negative 5. Again, we're talking about the roots. However, if we look at this equation, we have a GCF. Just like when we did factoring last unit, we need to pull out that GCF first. So I'm going to pull out a GCF of 4, and I'm left with 4b squared plus 3b minus 10, and it's still going to set equal to 0. So now, ABCs, A is 1, B is 3, and C is negative 10. Well, AC is negative 10, so that tells me I need to subtract. In this case, if I do 5 minus 2, I get my 3. So that means, again, we're still bringing down our GCF. It becomes 4x plus 5, x minus 2 equals 0. Now, from here, if we look, our GCF is a whole number, so we don't have to set that equal to 0. But we still want to make sure that we set our other two parentheses equal to 0. From here, we're going to solve for x. I'm going to get x equals negative 5, and x equals 2. That means my roots are negative 5 and positive 2. Those are my solutions, my x-intercepts, and it's where the graph will cross the x-axis. Our last example. If we look, it doesn't look like quadratic formula because we don't have a c. Well, if you need to put a c there, we can add a plus 0. But let's start by factoring out our GCF. They both have a g, so I'm going to factor out a g. I'm left with g plus 8. Well, now I don't have it in quadratic form, so I don't have to do my ABCs, but we need to still find our solutions. In this case, because we have a variable out in front, that variable needs to be set equal to 0, as well as my parenthesis set equal to 0. When it was a whole number, we don't have to set it equal to 0, because a whole number can't equal 0 unless it is 0. When it's a variable, you still need to set it equal to 0. Treat it like it's a second set of parentheses. Well, g equals 0, I don't have to solve that. The other one, I'm going to subtract 8. I'm going to get g equals negative 8. So my solutions are negative 8 and 0. You cannot forget that solution. 0 is still a number, so when that variable is out in front, make sure you make it equal to 0 and solve it if there's any work to be done. Bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.